Welcome, everyone. Good morning, good afternoon, or good evening, depending on where you're listening from. Thank you for joining our webcast today on an introduction to Git. I'm Stephanie from InCycle, and I will be your moderator for the webcast. I will be recording this webcast for your future reference. So after the webcast, I'll be sending out an email with the presentation, download, and a link to the recording. If you have any questions, though, throughout the presentation, please don't hesitate to type them in the chat box, and we will do our best to respond either throughout the webcast or at the time we have reserved for the Q&A session at the end. However, any questions we don't address during this webcast, we will answer in a follow-up email. Now let's get started by giving you a short InCycle overview. We've been around since 2002. We're both a Gold ALM and Azure partner. We're focused on 4 key service areas, such as Visual Studio ALM and TFS, Agile adoption and enterprise transformations, DevOps process and practices, and finally, we provide services around Microsoft Azure. So we really cover the full ALM, DevOps, and Azure-related spectrum. We also have consultants across Canada and the US, so we most likely have someone in your area. Now, before we get started on the webcast, I would like to introduce you to our presenter, Daniel Mann. Daniel is a senior software development consultant and a Microsoft ALM MVP. Before joining InCycle, Daniel spent over a decade designing and writing software and has worn many hats within organizations at various points in his career, such as a system administrator, developer, team lead, and scrum master. He's passionate about writing good, loosely coupled, easily testable software, unit testing, and modern DevOps practices. So without further ado now, I would like to turn it over to Daniel.
Hello, everyone. Thank you for the introduction, Stephanie. So again, good morning, good evening, good afternoon. Welcome to Introduction to Git. So Stephanie already gave a pretty good introduction to me, so I just want to start by talking about what our agenda is going to be for this presentation over the next hour. We're going to start off by discussing what Git is, because I'm sure you've all heard about Git. You're probably not necessarily familiar with what it represents in terms of source control for your organization. But we're going to define centralized version control versus distributed version control, because that's a really big distinction between Git and other source control tools. And understanding what a distributed source control system is key to understanding what Git really is. Then we're going to move on and talk about what Git looks like in the Visual Studio Team Foundation server and Visual Studio Team Services ecosystem. And then the question that I think a lot of you are going to be asking yourselves or are already beginning to ask yourself is Git the right tool for me, my organization, my team? And we'll start discussing what capabilities Git has that might make it a good fit for your organization. I don't have anything on the agenda for demo or Q&A, but there will be both a demonstration and Q&A. So let's get into things. As Stephanie said, if you have questions during the presentation, feel free to type them into the IM window. I'll be monitoring the IM window, but I might get I might miss it. So we'll make sure that we have time at the end to circle back, review, make sure that your questions are answered. So let's start with the easy stuff. What is Git? Git is a distributed version control system, and we'll be defining exactly what that means to you in a few minutes. And it's designed for the challenges of large-scale open source projects. So it was originally written specifically to support software development on the Linux kernel. It was designed by Linus Torvalds, the leader of the Linux project, and it's intended to support fast offline work. So the reason why Git was created was you have to think of kind of how the typical open source project looks. You have developers all over the world, and they're working on a common code base. They don't work in the same building. They don't work for the same company. They're probably not even located on the same continent. So those developers need to be able to take the code, work on it in a disconnected fashion, and then periodically synchronize their code with what everyone else has been working on. But at the same time, they still want all of the features that a typical source control system has, like branching and merging and the ability to review history. So those two kind of competing challenges led to Linus Torvalds to sit down and write Git as a source control system, because there was nothing else available on the market in the ecosystem that really fit that need to his requirements. So many years later, we have Git, and it's taking the software development industry by storm, even for applications that are not necessarily open source, just because developers prefer this model of working, even within the same company, within the same office, even if everyone's sitting in the same room next to each other, they still actually prefer this model. So before we discuss what a distributed version control system is, I want to take a step back and first discuss what a centralized version control system is. If you're familiar with SVN or TFVC or even older things like CVS, that's a centralized version control system. So the key distinctions that make something centralized is, not surprisingly, you have one central code repository. That's where all of your code lives. If you want to do something with that code, you have to go and you have to talk to that repository to get it. And of course, doing so requires a network connection or some sort of connection to that central code repository to perform, most operations. Not necessarily all of them, but most of them. For example, checking files out, committing files, performing merges and branches, and even going and viewing the history. You have to go and talk to that server to pull that information down. Now, some version control systems like TFVC have some extensions built into them to reduce or make it easier to work offline. But for the most part, at the end of the day, if you're using a centralized version control system, you're going to be talking back to your centralized server. And again, if everyone's in the same office, in the same building, and the server is located in the server room down the hall, then that might be fine, because no one needs to be able to unplug their computer and go somewhere else to work on it. But that's not always going to be the case. And another key distinction is you can retrieve just the files you need. So if you're using TFVC or SVN and you just need 5 or 6 files to work on one particular thing, you can just grab those 5 or 6 files. And centralized version control, as I've already said, it has a fairly limited capability for offline work, so I'm not going to belabor that point. Another really important thing about centralized version control is it's conceptually very, very simple. You have a server, you talk to the server, you check out that file. You edit the file, you're done. You want to put it back in there, you check it in, and it's done. And that's the simplest thing in the world. You don't need to understand anything about kind of the inner workings of your version control system to understand that model. Now, distributed version control is a very different beast. And one of the things I always say when I start talking about distributed version control, when I sit down and I do Git training with a team, is I say, first thing, forget everything you know about version control, because this is different. If you try and map all of those centralized version control concepts onto distributed version control, it's going to start to confuse you pretty quickly, because even sometimes the same terms are used in a slightly different context or in a very different context. So that said, in the distributed version control model, there is no such thing as a central code repository. The team defines the central repository by convention. Now, if you're using a Git host like Visual Studio Team Services or Team Foundation server, obviously your central repository is defined as TFS or VSTS. Or if you're using GitHub, your central code repository is obviously going to be GitHub. But there are some organizations that use Git just kind of on its own without any sort of special stuff built up around it, like TFVC or like TFS has. And so for those organizations, they just have like a server somewhere that hosts Git, and that's all. There's nothing else involved. And of course, that central repository could theoretically be someone's developer machine. Now, obviously, in the real world, you would never want to have someone's dev PC be a central repository, but you could theoretically do that. Except for a very specific set of actions, distributed version control systems do not require a connection to perform typical source control operations. So you can commit changes, you can branch, you can merge, you can view history, and you could do that with, if you had your computer and you got in a submarine and went 10,000 leagues under the sea, you could still do typical source control actions like write some code, commit it, branch, merge, and view history. The only time you actually require a connection is in the circumstances where you want to go back to that central code repository and either retrieve other people's changes to integrate into your repository or take changes you've made and share them out with other people. So it's very, very flexible in that regard, and it's very powerful. It's great for me because, I travel a fair amount for work. So I get on an airplane and I'm not going to pay for the internet connection in the flight, especially if it's a short flight. So if I want to do some work, I can do some work, and it's not going to stop me from committing my changes or experimenting and trying new things and saying, you know what, this branch doesn't work, and just throwing it all away. So it's very powerful if you travel a lot. Now, in distributed version control, you can only retrieve an entire repository, and we'll see why that is in a little bit. But basically, when you retrieve a repository, or in Git terms, clone it, what you actually do is you say, I'm taking the entire thing, the entire repository, all of the source code, all of the history for all time, and I'm making a copy of it on my machine. So that way I can interact with it on my machine without talking back to that server. So think of it, if you're used to something like TFVC, think of it as like instead of retrieving a specific subfolder underneath your TFVC repository, you just map your workspace all the way to the root and get everything in there. So in Git, you would be doing something like that. Now, the other thing, and this is really important, is Git has a higher learning curve. It is conceptually more difficult to understand, and it requires, some study and some deeper understanding in order to really use it effectively and understand what you're doing and why you're doing it. And we'll talk more about that learning curve later. So just to throw some graphics into the mix and kind of show how things look. So in a centralized model, and I'm going to pull up a laser pointer here. So in our centralized model, we have our central server with all of our source code in it. And then we have a bunch of PCs with, individual files that they've pulled down off of that server on it. In a distributed model, we have our centralized server with a repository, and then we have clones of that repository. So you see the little database cylinder cloned onto each one of those PCs, and that's a complete copy of all of that repository. So the way the workflow typically looks is something like this. So we have our remote server and we have our PC. And me, let's say that I'm using PC 1. I'm a developer, and I want to start working on the source code that's on this remote server. So the first thing I do is I clone that repository. And what cloning does, as we were discussing earlier, is it just takes a copy of that repository and downloads it onto my PC. So that way I have all the files, all the history, all the bits and pieces, the branches, everything that's in that repository is mine. So looking deeper into our repository now, you can see we have some changes. So let's, in TFVC terms, these would be change sets. In Git terms, we would call them commits. But basically, we have 2 commits in our repository. We have change 1 and change 2. So now I'm working entirely in my PC. I can go and I can commit, I can branch, I can merge, I can view history, anything I want. So let's say I made some changes to some files, and I committed those changes. Again, I'm doing this entirely offline within my repository. And you see that I have a new change that showed up here called my change. We're going to call it my change for the sake of argument. So let's say I wanted to take this change and get it out to my colleagues so they can pick up the work I've done and work on it some more, to make some more changes, fix my bugs, because we all make bugs, even the best of us. So I put some bugs in and I want someone to fix them for me. So what I would do in that case is, first of all, looking back to our remote server where I cloned from, someone else made a change. They have change 3. I don't have change 3. I have a different change that I made. So what I need to do before I can share my changes is integrate their changes with mine. So what I do in that case is I pull down the remote changes, and Git is actually pretty cool because it's smart enough to go and say, well, I don't need to get change 1 and change 2 again. I don't need to clone the entire thing. It can do some analysis and figure out, well, all I really need at this point is change 3. So it'll package up change 3 and download it. And then I have my change and change 3 all in my repository. Now, at that point, those changes still need to be integrated. So, like, think of a case where I made a change to a file and someone else made an unrelated change to that same file. Well, in that case, I can't just say, I'm going to push my change because my change contains some different stuff than what's in change 3. So the file would be out of sync. So before we do that, back in our local repository, we merge the changes that just came in from that remote repository with my change. So change 3 and my change get merged together into change 4. But now I'm done. I have a new change that represents all of the changes that have been made both on the remote end and on my end, and so I can push those back up to the remote server. And again, Git is smart enough to do the analysis and figure out that the only differences between me and the remote are my change and change 4. And so it packages those up, pushes them up to the remote repository, and then we're back in sync. And that, at a very high level, is a typical distributed version control workflow. So it seems like, it's extra steps than if I had just gone and worked in a centralized version control system, made some changes, checked them in, and then resolved merge conflicts. There's a couple of extra steps in there. I have to do some pushing, I have to do some pulling, and it's a paradigm shift for sure. So let's talk, why we have distributed version control, why we might want to take this approach. Well, first thing is the ability to work fully offline is just critical for some organizations. It's less critical for others. If everyone has their own laptop and they take their laptop home and work after hours at home, well, then the ability to work offline might be really good for them. If people travel a lot and they want to work on planes or in submarines, having that ability, again, is just absolutely invaluable. Now, if everyone's co-located in the same office, everyone has desktop PCs that they sit at, it might not matter as much to be able to work offline, but it is nice to have that option. It encourages you to commit frequently because committing is fast, it's local, and it doesn't interfere or interact with what other people are doing until you choose to have it interact with what other people are doing. So it gives you a lot of power to commit your code frequently and even encourage experimentation. And we'll talk about what I mean by experimentation in a couple of seconds. It makes it really, really easy to switch work because all of your branches are local. So, like, let's say you're working on something, you're working on a great new feature, and someone comes into your office and says, "Hey, there's a really awful critical bug that we just found. We need to get a fix for this out like this instant, as soon as possible." Well, if you were working in a centralized version control system, you might have to do something like take the stuff you're working on and shelve it, and then switch to a different branch, which requires going to the server to make that branch to work in. Meanwhile, in Git, if someone says, "We need you to fix this bug right now, stop what you're working on," you can just say, "Okay, finish the line of code you're writing, commit that change to your local repo," because again, no one cares. You're not sharing that with anyone yet. You make a new branch, which again is local, fast, takes a couple of seconds. Like literally, it's less than seconds. It's like milliseconds. It's pretty much instant. So you make your new branch. You switch to the branch. You go. You write your code. You fix the bug. Whatever. You commit that. You push that branch you made, or you merge that branch you made back into development branch, master branch, whatever, and then you push that while leaving the stuff that you were still working on in progress, that new feature, that's still isolated in your local branch. and then you can just switch back to that branch and keep picking and pick right back up where you left off. So it makes it really easy to switch work. And those two things combined makes it really easy to experiment and like go off on a tangent and maybe try something new. So like here's another scenario. I'm working on my new feature, and I think, wow, this class I'm working on is pretty bad. It really needs to be heavily refactored. Well, I could go and I could make a branch for my refactoring, and I can do a little bit of work and commit it, and then do a little bit more work and commit it, and then do a little bit more work past that and commit that, and basically checkpoint as I go. And then if at some point I say, you know what, all that stuff I did, it's not going to work. I realize that my refactoring is not going to be a good thing. I can just delete that branch, throw that work away, no big deal, easy. And again, getting rid of that branch takes a split second. It's pretty much instant. And it just lets you be able to, as you're doing that refactoring cycle, maybe you say, this isn't quite what I was expecting. I want to go back a couple of steps. So by being able to checkpoint your work as you're trying new stuff, it gives you the freedom to experiment, because you can always get back to where you were a couple of seconds ago without having to worry about breaking other people's code, or without having to worry about dealing with branching on the server, which even in TFVC, which by all accounts has pretty fast branches, it's still a slower process. Because the way branches in like SVN and TFVC work, and I'm sure everyone who's used those knows, you make a branch and then you have to download all of the code in that branch, and you have two folders on your PC, one with branch A and one with branch B. And so switching between those branches requires actually opening up a file in a different folder. In Git, via some very tricky file system magic, switching a branch actually changes the file system in the folder where your repository lives. So you check out branch A, and everything that's in that folder turns into branch A. You switch to branch B, and everything that's in that folder switches to branch B. So it's all kind of self-contained in the same folder. So it just makes that kind of that kind of context switching and branching really, really simple. The other really nice thing about it is there's incredibly powerful tools for viewing and rewriting history. So viewing history, I'm sure we all kind of understand what that means. But rewriting history, that might be something, especially to those of you that are very familiar with centralized version control, that might be something that's like anathema to you. Rewrite history. Why would I want to rewrite history? So here's my example. Let's say that we were doing that refactoring that I was talking about a few minutes ago, and as we're going through, we're making little checkpoint commits so that we have a place to go back to if we mess up. Well, when we're done with that, and again, keep in mind, we're working entirely locally. No one has seen our work yet. When we're done with that work, maybe we want to clean that up a little bit and get rid of all of those intermediate checkpoint commits, so what we actually ship off to the rest of the team when we're done is just like one or two commits that represent the major milestones of that implementation. Well, with Git, you can take those commits and you can do things like squash them or rebase them, and we're not going to go into a lot of detail as to what those terms actually mean and what they do, but you can squash a bunch of commits down into one commit and then ship that one commit off to the rest of the team. And so having that kind of power is, it's a really, really nice thing to have. Now, keep in mind, having that ability to rewrite history might not be something that you care about, and we'll talk about that as well. And the other thing, and I hate to bring this up, but Git really is increasingly popular. It's the hip technology that everyone is kind of getting on board with. I don't think that something is necessarily good because it's popular, but regardless, Git is a popular tool, and if you're looking to attract the developers that are just finishing up in college and kind of getting out into the working world, well, they've probably been exposed to Git already, where they probably haven't been exposed to SVN. So just kind of having that popularity, it's winning the popularity contest right now, for better or worse. So having that popularity And using that tool will help a younger developer or a newer developer fit in with the team more easily and get productive more easily than them having to sit down and learn SVN when they've never even heard of SVN before. So let's talk about why not distributed. Because believe it or not, even though I like a lot of things about Git, I don't think that it's the end-all, be-all of version control. I think that there are reasons not to use distributed version control. So my rationale there is it is harder to use day-to-day. It's harder to learn up front initially. And as we've seen in the little walkthrough where I was talking about committing and pushing and pulling, there's a little bit more plumbing work that you have to do day-to-day. It's not lights off, I write my code, I hit commit, or I hit check-in, and the code's checked in. There's more steps that you have to follow through. And it's not that it takes a long time to get over that learning curve and start being productive. It's just that it might not be something that your team is not necessarily ready to take on that kind of educational burden. In my experience, and I typically work with larger enterprises, banks, insurance companies, that kind of thing. In my experience, few closed source and non-open source projects need that kind of ability to rewrite history. Rewriting history is awesome when you're going and you're working on a patch for a specific bug, and that patch might take you a couple of weeks or months to get done, and then you want to ship that bug patch off to the repository maintainers so that they can say, well, yes, we like this bug fix, we're going to integrate it, or say, no, we don't like this bug fix, we're not going to integrate it. And then let other people that are maintaining their own forks of that project take just the patches they want. Having the ability to rewrite history helps you work in that kind of fashion and be able to do things like submit little patches, even though that little patch might represent a lot of work to you. And in my experience, closed source projects don't really need that. Git does not handle binaries very well. There are certainly ways around that I'm not really going to get into, but you can you can add support for binaries into Git. But what you have to keep in mind is Git is really smart about text files. Like it can version a C# code file like crazy. Like it compresses, it does diff comparisons. Internally it's really smart about that. But for binaries, it doesn't know what to do with binaries. So if you put a binary into a Git repository, and remember, every time you clone a repository, you're getting all of the history, all of the files for all time. So every time you put a binary into the repository, it grows by the size of that binary. So if you put 10 1 megabyte files in there, or 10 versions of a 1 megabyte file, your repository is going to grow by 10 megabytes. And like I said, there are ways to kind of get around that or handle binaries within Git. But if you typically put a lot of binaries into source control, Git is not a great choice. And something, especially again with larger enterprises like banks and insurance organizations, in distributed version control, security is defined at the repository level. So in TFVC and centralized version control, I can say this folder is locked down. Developers cannot get to this folder, or only certain developers can get to this folder. In Git, I can't do that. I can say you can clone this repository, or you can't clone this repository, or you can view it, but you can't submit changes to it. But all I can do is enforce what happens at the time of cloning or at the time of pushing. I can't control what happens once they have that repository on their machine. It's theirs. They have a copy of it. They can do whatever they want. So if there's code in there that people shouldn't be able to see, well, they'll be able to see it if you're using Git. And again, there are ways to mitigate that and manage it. But if code security between different developers or different teams within your organization is a big concern, then Git might not be a good solution for you. So let's talk about Git as it applies to Visual Studio and TFS. A couple of things I always like to point out is that Git in Visual Studio will work regardless of your Git provider, even against a local repository. So in Visual Studio 2015, when you create a new project, there's a checkbox for add to source control and it's checked by default now. And the default is going to be Git. Because basically you start a new project, why not source control it? You don't need to share that with anyone, but having that kind of offline work capability and that branching, committing, checkpointing, experimentation workflow is nice, even if you're developing something smaller, throwaway. So like every time I start working on something, I'll put it into a Git repository. I might not ever commit to the repository, but having that option there if I need it is great. I love it. And you can see that Visual Studio actually has a GitHub plugin. So if you want to use GitHub for hosting your Git repositories, you can do it right from Visual Studio. And same goes for like Team Foundation server. So here's something on Team Services, my Sandbox account. And then we just have a bunch of local Git repositories. So, I'll open something up in Visual Studio or clone it from someone else. And I'll just open it up and work on it right out of Team Explorer here. And Team Explorer, for those of you that are familiar with Team Explorer as it applies to centralized version control, you see that it looks a little bit different when you're connected to a Git repository. So you have changes, you have branches, and you have synchronization options for doing pushes and pulls. And that's if you're connected to a Git repository that's not hooked up to Team Services or TFS or GitHub. If we look at how it would look for Visual Studio Team Services or TFS, we have changes, branches, sync, and settings, but we also have work item management. We have the ability to manage pull requests, which we'll talk about in a little bit, and also view and manage builds. So it gives you that same kind of capability for work item management and builds that you're already used to if you've been using TFS before. And then for GitHub, and this is a real project that I'm working on, you can see that there's also changes, branches, sync, settings, and pull requests. But then there's some GitHub-specific entities like GitHub Pulse and Graphs, Issues, and Wiki. So, there's a lot of different plugins for managing Git regardless of your environment. Now, in Visual Studio 2015, at least as of Update 1, there's first-class IDE support for Git. So when you're connected to a Git repository, it's actually going to show you right down in the bottom right corner what repository you're hooked up to and what branch you're working on. And you can click right in on that branch and switch branches right from the IDE. So Visual Studio is just fully embracing Git. Now, within Visual Studio Team Services and TFS, Git and TFVC are both supported in the same project. So you see I have a Git Sandbox project with a TFVC repo that just hosts standard centralized TFVC version control. And then I have two different Git repos. You can have one TFVC repository in a project and unlimited Git repositories. And the reason for there being one TFVC project per project is just because of a technical limitation. That's just how it's designed, how it was designed. But you can have as many Git repos as you want. And of course, you can manage your repositories out right from the web. So you can rename a repository, you can delete it right out of the web interface. You have a very, very pretty, rich web-based history view. So you can see, you can see how this branch is evolving over time. And this is something from Microsoft. So you can see a few navigation bug fixes found in S80, refactoring bits of navigation JavaScript, and that encompasses these two different commits. And you can actually even see the relative size of the commit. That's what that little bubble means. So the bigger the bubble, the more files change, and the more files change across. These. Not only the more files change, but the more the individual files change. So if you have one big file that changed a lot, you're going to have a bigger bubble. You have some really nice tools for comparing branches. So you can see, in this case, we have a master branch, which is the trunk or main or whatever you want to call it in centralized terms. In Git world, it's called the master branch. And then I have two branches from there, dev and new feature. And so you can see exactly how far ahead or behind each of those branches are. So you can see the dev branch is 3 commits behind master, but 1 ahead. So that means that in order to sync everything up, I would have to first pull down those dev changes to master, and then also push that one change we've made back to master. So that would be, so that gives you a nice view of where things are relative to each other. Git has a full, very robust code review workflow via something called a pull request. So what a pull request means is, and a pull request, by the way, let me just start by saying, it's not something that's built into Git. It's not a Git feature. It's a common workflow that's built on top of Git. So like GitHub has pull requests, and TFS has pull requests. But it's not because that's a Git feature. It's just a feature for managing your Git workflow that's built on top of it. So what a pull request represents is you go and you work in a dev branch and you write some code for a while, and you want to merge that into the master branch. So you want to submit that back to the master. Now in TFVC, you would just do that merge and it would be done. But since Git has a more kind of open source thought process, a pull request lets you say, I want someone to review this change before it's merged. So it gives a repository maintainer or a branch maintainer the option to go through and look at that change and enforce quality gates. So you can see there's the ability to do inline annotations and kind of have a discussion about the change before it's merged, before it leaves your development branch and goes back into the master branch. And even within that, you can enforce the quality of your pull requests via what's called a branch policy. So, and this screen is big, so I'm going to break it down into a couple of different sections. So the first option is the ability to force it to require an automated build from the TFS build system to run. So basically, when I open up a pull request, the first thing it's going to do is run this particular build. And if that build fails, if my unit tests fail, if the code doesn't compile, that pull request is going to be done. We can't merge that change because we don't have a good build yet. And if you're used to TFVC, if you think of a gated check-in, this is similar to a gated check-in in that it prevents bad code from making it into source control. You have the ability to enforce requirement linking. So you can see I have a checkbox, check all pull requests for linked work items. So just like with TFVC, if you want to link a work item to that commit so that you can trace back to the implementation of your requirements from your requirements, you can enforce that and, again, not allow that merge to happen if those links don't exist. And you can also enforce mandatory code review. So you see, in this case, we have a minimum number of reviewers per pull request of 2. So in order for that to be approved, 2 people have to go and look at it and say that they are okay with this being merged in. And you can even require specific reviewers for a specific path within the repository. So like, let's say you have a database project. Well, maybe you want the DBAs to have to review changes that are made to the database stuff, but you don't care about the DBAs reviewing, middleware code. So you can actually set it up so the DBAs have to review a specific database project subfolder, but nothing else. And so I'm going to go into a demo and show you some of this stuff in a few minutes, but let me just start by saying, should you make the switch? And my answer is yes, if you work offline frequently, if your software is open source, and if you want to branch and merge frequently. If you really like that idea of being able to work offline and experiment and commit frequently and just kind of go back to an old commit, if you don't like what you've been working on, and package those changes up and shift them off to the rest of the team when you're done, then absolutely, Git is a great fit for you. Just keeping in mind that there's a learning curve, and it's going to take you some time to get used to it, especially if you have if you have a team with a wide array of skill levels. So someone that's been writing code the same way for the past 30 years, they might not necessarily want to kind of make that conceptual switch and learn how to use a brand new tool. So you have to kind of take that into consideration. But typically, if you can answer yes to those questions, then by all means make the switch. Now, I would say you shouldn't make that switch if you never work offline. Your software is closed source, so everyone comes in to work, they sit down at their workstation, they make changes, they commit their changes, and that's kind of the end of it. And it's never shipped off to anyone else. It's never source code never goes out to the world at large. And something that I always like to say, if the developers on your team are happy and productive using something that's not Git, don't make the change just because all the cool kids are using Git. Because I see a lot of teams that kind of fall into that hole or that pit where they say, well, Facebook uses Git and we want to be successful, so therefore we should use Git like Facebook because that will make us be successful. And that's a bad way of thinking about things. So if everyone's happy and productive using TFVC or SVN or even CVS or VSS, and I hope you're not still using VSS, but if you are and you're happy with it and you have no problems, keep using it. It's not going to hurt you. And the last reason you should not make that switch is, like I said earlier, if you require really stringent security around who has access to your code and permissions for that code, and history of the code, then you probably don't want to use Git because you can't lock it down quite as tightly as you can other tools. So let's talk about some quick best practices for using Git. The first is don't panic. It's new. It's going to be scary. You're going to get frustrated with it at first, but just don't panic. You'll get used to it. Don't put binaries in Git repositories. Instead of putting binaries into Git repositories like I was talking about earlier, that's bad. You can manage binary dependencies via like NuGet or NPM or some sort of package manager. And there's also a binary management tool called Git LFS, but I'm not going to go into what that is. Typically, you want to keep your repository small. So like one application would be in its own repository. You wouldn't put 30 different applications into one repository. You would put one application into one repo. If you start using Git, branch earlier and branch often. Don't work directly on the master branch because Git is all about branching. And it makes it really easy to branch. It makes it really easy to merge. And it really encourages that kind of workflow. And I know that a lot of people are scared of branching and merging based on how tough it can be to do in older version control systems or in SVN. I know that branching is kind of a nightmare and merging is just as bad. Well, Git is designed with branching and merging in mind, and it makes it really easy to do it. So don't be afraid of doing that. And the last thing, and I can't stress this strongly enough, read the documentation for Git because it is fundamentally a command line tool. So there's a lot of stuff that you can do from the command line. It's really powerful. But it has a lot of different weird command line flags. So you just want to, go and read the documentation for Git because hopefully it will explain a lot. So we have about 15 minutes left. I did want to do a demonstration, but I also want to just see about answering any questions that may have come up. I see a couple of people saying they can't hear anything, and I hope that I've been talking for the last 45 minutes and people can hear me. So what I want to do is I want to open up the floor to questions a little bit. And if we don't get any questions, then I'll do a demo for the last 15 minutes. I'm not seeing any questions, which I'll take as a good sign. If there are no questions, then I always I see someone calling for a demo.
This is Yuri Geller from Cigna. I'm wondering if I missed most of the presentation. I'm wondering if you show the pull request and how to organize security around pull request. And again, it just if you have time or you have desire to show the pull request and security around it.
Okay, so I'm getting a lot of calls for demos, especially of pull requests. So I think I can do that. So what I'll do is I'll show you a couple of things. So first, just let me show you the repository I have that I'm working out of here. I have a repository for an actual project that I worked on with the ALM Rangers, and this is open source. This is actually on GitHub. But one of the nice things about Git is it's easy to migrate repositories. So I downloaded the repository from GitHub. I cloned it, and then I pushed it to Visual Studio Team Services for my demonstration today. And when I did that, I got all of the history. So if I go and look at the history of my develop branch, you can see all of the changes that people have made, going back months and months and months. And I didn't have to do anything special for that. I just got that for free with Git. So I have two branches. I have a development branch and a master branch. And I can manage who has the ability to commit changes into these branches via pull requests. So what a typical workflow would look like, if I go to the work view, and I go look at my backlog, in my current iteration, I have a product backlog item for implementing a new feature and an active task for improving the code around that feature. So when I open that task up, you can see there's a little development section that says, development hasn't started on this item, create a new branch. So I can click that, and it'll actually automatically create a branch that's linked to that requirement for me. And I'm going to base this branch off of my master branch. And so I'm going to call this feature/improve code. So I'm going to make a new feature branch for myself called improve code. So now I have this branch, and this branch only exists in the repository that's hosted in Team Services right now. So if I go into Visual Studio, the first thing I have to do is just sync up my repository by fetching. So I'm going to fetch, and when I do that, it's going to synchronize those branches. So under my branches view, if I go look here, I can see my local branches that are all mine and aren't necessarily shared with others. And then I can see the branches that are in the remote. So you see I have this remote section, remote/origin. I have develop, which is tied to this branch, master, which is tied to this. And then I have that new branch that I just created on the server. So I can make a new local branch from that, switch to it, and I'll make a quick change. I'm just going to make a quick method here. So I just made a new unit test in my unit test project that asserts true is true. So this is a bad test, but it will pass, and that's good. So I'm going to commit this change to my local repository. And I'm going to make sure that it's tied to that work item. So any change that I make where I want to tie it to a work item, all I have to do is put a hash mark or an octothorpe or a pound, whatever you want to call it, and say the number of the commit, or the work item, rather. So I commit that, and then I can sync that back up to the server, or I can create a pull request right from Visual Studio. So if I go to pull requests, I can make a pull request from this local branch to this remote branch. And I'll give a title for it called, how does this look? I hope it looks good. So that's my title and my description. So I do that, and it pushes that change, and then I should have a pull request open. I was having a problem with my Visual Studio, so let me do it from the web instead. So you can see review changes in feature/improve code relative to, and I'll do that relative to the master branch. And so you see that work item is already linked in there. And my reviewers are going to be, by default, the members of the team that I'm working on. So I'm going to open up that pull request.
Daniel, there's a question here, if I could read it to you real quick. It says, is it possible to do squash operation from Visual Studio?
From Visual Studio, no, I don't believe so. But as part of completing a pull request, you can have it do a squash. So when you do that merge from your pull request, there's a checkbox, and we'll see that in a minute, where you can have it squash it. And I see another question for creating a new repository from scratch, and I can show you that. I'll show you that in a minute. I just don't want anyone to think that I'm missing them. So anyway, here's my I'm sorry, is there a question?
What is a squash?
A squash is basically taking a series of commits and combining them into one.
Okay, thank you.
Mm-hmm. So what we see here is on my pull request, I can do full request annotation. So like I have this change here, and me as the reviewer, I can go and I can say, why are you doing this? And I can put an @ sign to mention someone, or even put a work item link in there. So I type the hash sign, and it shows me all of my tasks and product backlog items. So I can just link those things in there. And then when I create that, I can assume that someone's coming to look at this later. They can go and they can have a conversation with me about it. So I can say, blah blah blah. And then this is actually marked as an issue, so its status is active. So I could go and I could say, I'm not going to fix this. And then as the reviewer, I can respond whether I approve, whether I'm waiting for a response from the author, and you can see it reflects up here, or whether I don't like it and I'm rejecting it. And what's cool is you can see this build succeeded. So it actually ran an automated build, and we can go and click on that and see the build. So it's going to take me over to that build that I had set up to run. And you can see the associated work items and associated change sets with that build. And you can even see all of my unit test results. So that's pretty cool. So now that I did that, all of these check marks are green, so I can complete that pull request. And so you see, and for the person that was asking about squashing, so you see there actually is the ability when you're completing a pull request to squash changes. And we can also delete that branch because, again, deleting a branch is fast and easy. So it's easy. So if we want to have that branch get deleted, we absolutely can. So I'll say complete. And then because I've done that, only then is that change committed. And you can see it says merge successfully, and it shows me what commit that's going to be in my master branch. So how that's set up is on this version control tab. For a given branch, you can define what are called branch policies. So you can see that my master branch is pretty locked down. I'll zoom in a bit. So I have a build definition for my demo application, and I want that to be forced to build. I want to force people to have to link work items. And I'm not requiring a specific number of code reviews, but I am requiring a code review. Now, there is security that you can define at the branch level. So you can say, someone can contribute to the master branch or administer. But keep in mind, that's only when they're pushing changes to the remote repository. So if they clone that repository, they absolutely have access to do whatever they want in their local repository. All it can do is block their ability to push changes that they've made to that branch. Does that make sense?
Yes. Thank you.
Excellent. And so for the individual that wanted to see how to create a repository, that's super easy. So what I'll actually do is I'll open up a new instance of Visual Studio. And then after that, I'm going to wrap things up because I want to talk about some excellent training options we have and migration options so we can help you out if you want to make the switch. And I do not want to forget to do that. So I go to my Team Explorer. I hit the little Connect plug. And you see how I have all of these repositories. All the way at the bottom, I have local Git repositories, and I can just say New Repository. I can put a local repository wherever I want. I hit Create. Oops, sorry, that already exists, so I'll just Daniel Repo 2. So I'll create that. And there, now I'm working in that repository. And I can make a solution now, I can create code, I can do whatever I want, and I have the full source control experience. So I'll just create a console application. So now that I did that, you can see, hey, look, it's adding a bunch of files to source control. And I'll just put a commit message in there. And now I have source control. And it's all local. I'm not connected to any servers. To share this repository, so the question was, how do I share this now that I have it? So I can go to the sync tab, and I can enter the URL to a repository. I can publish it to Team Services. I can publish it to GitHub right here out of the sync tab. So that's all, unfortunately, I have time to show you. There's a million other things I want to show you, but I want to just, first of all, thank you for coming. And second of all, I want to show you these awesome courses and workshops we have for getting started with Git. So we have a couple of options. This Git Fundamentals workshop, or course rather, is a really deep dive into what Git is, how it works, and how to do all of these cool things like rewriting history and squashing and rebasing. And it helps you kind of get started with Git as a source control tool. Then we have a second course on how Git works in Team Foundation Server in Visual Studio. So that's where we figure out, how to set up things like pull requests and proper branching and merging structure so your team can work effectively within a Team Foundation Server context. And then we have a workshop where we sit down with you and we help you figure out how to get your code out of something like SVN or TFVC and into Git, and how to set things up for branching and merging and really understand how to work most effectively with it within the Microsoft ALM platform. So I'm going to leave this up. I want to just say thank you very much, everyone, for attending. I hope that you learned a lot of stuff. If you have more questions, you can feel free to stick around and ask them past the end of the presentation, or you can send us an email and we'll be happy to get back to you.